Hey physics kids, how you doing? How are you doing? You know, we just got done with CV, didn't we? Constant velocity. That's a basic type of motion. Now, just because it's kind of easy doesn't mean that it's not very common. There's a lot of things in our universe that travel at CV. We can do it in our car with our cruise control. But you know what? Life would be pretty boring without change. You know, with CV, our speedometer never changes, right? Objects stay at one speed, one velocity. But we really need to be able to change our speed. And that's kind of the basics for the next two units, Unit 4 and Unit 5. So we call this CV, but now we're going to use the term CA, constant acceleration. Now notice, I've got a plus sign in front of here and a minus sign in front of there. So we can have a positive constant acceleration. That'd be my speedometer going up. My object is getting faster and faster and faster. With negative constant acceleration, my speed goes down. So that's what these really next couple weeks are about. It's about changing velocity or changing speed. We can get faster, we can get slower. Hey kids, you've been doing this stuff in your car or when you take trips or get on your bicycle or whatever. You get faster, you get slower. Now, with CV, kids, remember, now hold on, take a time out. The two questions that we want to often answer in physics. What are those two questions? How fast and how far? So how fast is something traveling? How far did it travel? So we like to answer those two questions. With our CV sort of unit, we could really answer both of these, or one equation can really help us with both concepts, right? X sub F, remember what that stands for. That's a final position. When we take that and subtract the initial position, we get how far the object moves. All right, this velocity is telling us how fast. So this one equation can really help us with both sorts of answering both sorts of questions. But acceleration is a much more challenging sort of concept because my speed is changing. So we're going to end up really having an equation that can help us determine then how far an object moves when it's accelerating. And then we can also then develop an equation of how fast something is moving. Now, look at this how far equation. Notice then we've got a variable time with the square there. Okay, now that's whenever we have a square with a variable, we know then we have a parabolic or a quadratic. When we graph things, it's going to be parabolic. Notice how similar this is to then our equation, our general equation for quadratics. So this how far tells us then it's basically a position time graph. Right? That's a position time graph. So with CV, our position time graph was a linear function. But now with CA, our position time graph is going to be parabolic. It's going to be a little more challenging. I'm going to explain that in my notes later. This little video is just kind of an intro. So our how fast equation, now look, it's a linear function. So this is going to be then a velocity time graph. And I talked about velocity time graphs, called VT graphs. I talked about velocity time graphs in the last unit. We didn't really have any questions over that on the assessment. But I did say to watch that end of that, the last video, or part 4 of that video. You might want to go back and look at that again to get a nature of what a VT graph is. But a position time graph shows us how far an object is going or has moved, and a velocity time graph is saying how fast that object is moving as a function of time. So this is going to be a linear function. So basically what we have is going to be a diagonal. So with CV, we had a diagonal with the position time graph. Now with CA, we're going to have a parabolic or a quadratic function with the position time graph, but we're going to have a linear function with the velocity time graph. Listen, I've been talking over 5 minutes. That's enough. But this is the basic idea for these next couple of weeks. Objects that get faster, faster, or objects that get slower and slower. Oh, I'm ready to go. Let's go.